So dear friends, so in final presentation at MIT Boston, so finally our team departed from Dayalbagh, Agra and reached Boston. And our presentation was in October year 2017. So these were teams, again I want to tell, so these were our teams and they have participated in iGEM-2017. So again I am telling, so our project was bio-weeds for removing heavy metal toxicity from industrial effluents. And this is the Gyan Jamburi that was held in November 19 to 13 in Heinz Convention Center. And this is our team logo. So we were wearing the t-shirt and each and every t-shirt having the logo with the DEI team. And this is our project theme, that is the BECO. So how BECO will be going to or already remove the heavy metals from the industrial effluent.
Also hold some amazing facts. Facts like these rivers form a river system which covers about 82% geographical area of our country. And this makes our country rank 4th in the list of this makes India rank 4th in the countries having largest water area. But in the present scenario, the reality is something very different, and the reality is that these rivers are now used as open dumping grounds. Open dumping grounds for sewage, domestic, all kinds of waste. And now these rivers doesn't only contain the solid plastic waste, but these rivers are choked with heavy metals. And what are the sources of these heavy metals? The sources of these heavy metals are the industries present on the banks of these rivers. Industries like electroplating industry, battery industry, pesticide industry, all these industries for their dump use heavy metals as their raw material and pour their unregulated and unmonitored waste into these rivers directly. And from these industries, the final sink what heavy metals form is into these rivers. So, one thing that we analyzed through the progress of this project is that our government has laid different stringent laws to regulate the content of heavy metals, but still these industries are without thinking dumping their waste into these rivers. And things that we analyzed through the progress of this project is that the problem doesn't lie with our government but with our own people. And the problem is the lack of unawareness towards the aspect of heavy metals, the lack of unawareness that we consider solid waste, plastic as the only waste, despite without ignoring the fact that heavy metals are equally harmful and toxic to our environment as well as for us. So, as for this project, we make sure that this project will not remain confined to labs. We will bring it to the lab and create an aura of awareness among the common people, students, and especially the factory workers and owners, so that there is an awareness and understanding about the toxicity of heavy metals. Another aspect to this situation is that in India, water from these rivers that is toxic of heavy metals is used for agricultural practices directly or either through sewage treatment plants which have no monitoring system for the heavy metal content, and thus from the rivers these heavy metals are incorporated into plants. Like from industrial effluents, these heavy metals move into plants, incorporated within them, and these crops are finally supplied to the normal citizens of our country, to normal humans. And from the marine ecosystem, these heavy metals are finally transformed into human biota. And India is an agricultural-based country. And if this is a problem, then we are doing something really wrong. what is the potential of heavy metals, what they can cause extreme diseases. All those specified diseases we learn in biomedical books are actually caused by these heavy metals. From the organs like liver, brain, all of these organs are affected. Different types of liver toxicity, hepatotoxicity, all kinds of toxicity are actually caused by these heavy metals. And one thing that we feel that there is a need of unawareness is that there is a continuous publication of articles in newspapers, but still the general people of our country are completely ignorant of the fact what heavy metals can do. And thus, heavy metals are affecting the human population, our villages, and not only villages, but entire population of our country, and yet we are paying no heed to this fact. And thus, these heavy metals are appearing as silent killers, killing the normal functions of our body. So, understanding this problem, understanding the seriousness of this problem, of the problem of heavy metal toxicity, our team proposing a solution, and our solution is BECO. BECO, B stands for beads, and ECO means E. coli. So we are fabricating beads within which E. coli will be present. How is this E. coli different from others? We will see in the further slides. So the elementary idea of this project or BECO is to design a very strong promoter which overexpresses our gene of interest. Our gene of interest is the metallothionein protein. The promoter we will be using is of viral origin, that is from Mirabilis mosaic virus. So for easy working of this project, we divided our project into 3 strategies. The first strategy was selection of parts. The parts we needed for this project were first a very strong promoter and the gene of interest. The second part was the gene of interest, that is the metallothionein protein. Strategy 2 was bringing these 2 parts together into a final construct, and thus the second strategy is the development of these parts. The third strategy, that is the most interesting one, is the validation of designed construct into our BECO. Now coming to the strategy 1. As I already mentioned, we needed 2 parts. The first part was the promoter part. So we chose a promoter viral origin, that is from Mirabilis mosaic virus. The reason for choosing this promoter was that the functioning, the expression of this vector was already researched and published in a research paper authored by our own mentor, Dr. Rajiv Ranjan. So we settled down with this promoter. Second, gene of interest, that was metallothionein protein. We settled down with 2 metallothionein protein. The first one was T4MP3 and HMP3, top 4 metal binding protein, and the second one was human metallothionein protein. One thing I would like to mention is that the promoter we chose was further modified by reshuffling it. We studied the cis elements, reshuffled them so that the promoter shows a better expression. Apart from this, we also innovated this promoter by adding a URM gene section of photosystem 1 gene of plants. This idea was also from a research paper published by Ranjan et al. So therefore we modified this promoter. The gene of interest was also modified using the codon optimization techniques, identity codon wise softwares. The characterization of this promoter, the in silico characterization of this promoter was done by our team, the student members. However, the functional validation was done by our lab experts, our mentors, because we were very constrained of time. So therefore, functional validation, the photoclass assay was actually conducted by our mentor. Now coming to the second part, that is the metallothionein part. So we used a part of previous iGEM team, that is BBA-K14. It was a part produced by Hanover team 2014. This part was modified by our team using codon optimization, and this part is known to bind. It is produces malactulant protein and is known to bind to top four, or rather four heavy metals, that is zinc, arsenic, copper, and cadmium. So this is what we did. We transformed the simple T4-MBP, top 4 metal binding protein, into modified top 4 metal binding protein through IDT softwares, codon bio software. So we actually improved this part. Now coming to strategy 2, that is the development of DNA part. So when we have selected a promoter and we have selected our gene of interest, that is T4-MBP, it now was a time to bring these two parts together. So to bring these parts together, we performed cloning in a puff-based vector, where the promoter part was cloned in the downstream region between the link 3 and eco-carbon sites, while the protein part was coded between the ZO1 and SACRON sites. And these are results of the cloning, where we validated the size of the bands. This final construct took us to the strategy 3, that is the validation of this construct via our BECO. And for this, we transformed this construct into E. coli PL21 through heat shock methods, and the successful recombinants were then used to prepare the biobeads, that is BECO. And the protocols we used was from a paper authored by Daylbagh in 2012. So for the bead formation, we used sodium alginate beads, and we tested several concentrations of calcium chloride with sodium alginate. And after several experiments, we fixed one concentration, that is the 1% sodium alginate in 100 millimolar calcium chloride. The reason for choosing this type of concentration was that beads formed from this concentration showed better shape and better pore size. So we fixed this concentration, and the E. coli producing our gene of interest was immobilized into these beads. So once these beads were formed, it was the time to test these beads by treating these beads into water samples. So for testing these beads, we took 3 samples. The first sample was an artificial water, which is very analogous to the industrial effluents, the water coming in form of industrial effluents, where we dissolved copper chloride, zinc chloride, and cadmium chloride in the following concentration, 0.5 millimolar concentration. The second sample we took was the water from the sewage treatment plants, the inlet and the outlet water. The efficacy testing of these beads were done using 2 techniques. The first one was the AAS technique, and the second one was the ICP OES technique. So these 2 techniques are applied to test the efficacy testing, of our beads. Arsenic was not tested because of the biosafety issues. Now coming to the results of this project, and it is something mind-boggling and maybe a very bright provide us with a very bright future aspect. That is that in artificial water, there was about 83% decrease in the copper concentration, and 50 and 83% decrease we saw. And one was the 83% decrease was through MMP metallocyanine, while 50% decrease was through MMP T4-MBP. So these are the results and similarly for zinc, we got 21.63 reduction in the initial copper concentration, in the zinc concentration and simultaneously 21.63 and 31.02 decrease in the zinc concentration. So these results clearly indicate that our beads are working, and not only working but efficiently working. So coming to an overview of this project, our promoter is actually the hero of our project, the Superman. And when the Superman actually needs its power, that is MP4 MP3, that is the calculatory, when the superhero needs his powers, it was a time to entrap the superpower into a vehicle, and that was our beast, the Bego. And this Bego was in a mission to redeem this world, and to deal with the heavy metal pollution. So these beads were placed in water having several heavy metals, and once these were tested into beads, the water was converted from the bad water into pure water. So our superhero was working. So coming to the conclusion, Team DEI Agra has taken a step and initiated a project for removing and dealing with the heavy metal problems, and we accomplished our objective of chlorine the calcium downstream by chlorine the calcium protein downstream of a synthetic promoter, which are successfully immobilized in form of Bego. Coming to the collaborations, we did collaboration with iGEM-2017 and Govt. We are really thankful to the team iGEM-2017 because this was a team which actually helped us with our wiki. We had a disastrous adventure with our wiki because the persons doing our wiki, the student members doing our wiki, couldn't do it due to some really unavoidable reasons, and therefore at the very last moment, this team actually helped us. This is a fellow Indian team which helped us in doing a certain amount of our wiki, which you can actually see, which you have already seen. So coming to the achievements, we fulfilled the entire criteria of this item competition. For bronze, we did all these following criteria: wiki registration, wikis, submitting the DNA samples to the registry, interrupt study. For silver, we experimentally validated at least one, we modified the previous existing part of hydroprotein, DDK14. We carried out our collaborations with NIPA and iGEM-2017, the fellow Indian teams. And we do have a human practice page on our wiki, though at the very last moment, but we do have. So coming to the acknowledgement, we are thankful to Department of Biotechnology India for sponsoring our team, IDT for sponsoring us, RPI, this is the Alumni Association of College, for sponsoring us and booking our hotels in America, for making our pleasant stay in America, our college for supporting this team, the engineering technology, the technique ICP OES was of engineering technology. So we really appreciate and acknowledge our partners. So this was our team, the year 2017. Our mentor, Dr. Rajiv Ranjan. We are extremely thankful for him for providing the guiding hand to this project. So with this project, we have immense hope, rather belief that our coming generation, your coming generation, have a chance to gaze the blue skies, the blue rivers, and the beauty of nature lingers now and forever. Thank you.
So just you have seen that our team members were presenting at MIT Boston. So after a series of poster and oral presentation, finally our team members, Team DEI, bagged bronze medal. So thank you to our head, director sir, whole faculty members of the department, friends, family for supporting us. And last but not least, I am also grateful to whole team members for this big achievement. So you can see how students are very happy and enjoying. So this is the competition. After competition, students are at MIT Boston. So this is again we have visited MIT institutes with all team members, and this is our team. That is called also what called part of the team. So congratulations DEI, congratulations our team. So thank you very much. So these are the media coverage. So these are big achievements published in different news like Hindustan, Dainik Jagran, and they